All right, I want to show you our latest feature called model-based custom entities. Textual already supports custom entities via regex, but in a lot of situations that's not super useful because lots of entities you can't identify via regex exactly because they can be too complex. This new approach allows you to train your own private NER models on your own data. The approach essentially uses a large language model to annotate data, and then with those annotations we can fine-tune a BERT model for speed and efficiency. I'm going to today use a data set of unstructured medical notes, and I'm going to train a model to identify biomarkers within the medical notes themselves. To get started, I'll give my custom entity a name. We'll call it biomarkers 2, because I already have another biomarkers model. And I'm going to provide some annotation guidelines. This is essentially telling the large language model how to identify the entity. I have this description here. We want to identify biomarkers in medical notes. We want to include both the name of the biomarker, e.g. sodium or Na, and also include the numerical or descriptive value as well as any units that follow. Now we're going to upload some files so that we can begin the annotation process. All right, let's begin uploading files. We're going to upload 5 medical notes to begin. As we process these medical notes, we're essentially going to be feeding them into a large language model to begin the annotation. Once the large language model is done, we'll have a set of annotations that we can review. We're then going to essentially go through an iterative process of adjusting our annotation until we feel that the LLM is doing a good job annotating these 5 medical notes. So the first medical note's already done, so let's look at it. So going through this, we can see that the large language model already made a mistake. Reduced ejection fraction, that's really not what we're looking for here, so let's remove that. We can save and mark the file as reviewed. We can go to the next file. This is looking a lot better. So I see a lot of biomarkers here. I see one mistake right there. Scrolling down, this looks pretty good. It's including both the biomarker name, it's including the numerical value, and if there's units available, it will include those as well. I'm happy with this. We can save. We'll go to the next one. That's not really a biomarker, but it is talking about something called BNP, but not really what we're looking for. That looks good. Things that aren't reported, we're going to exclude. That's good because now we're getting an actual number along with it. Again, not reported, we're going to exclude. Going down. Things related to diet, let's kind of exclude that for now. Those aren't really biomarkers, they're just kind of suggestions. All right, we're going to save it. Go to the next one. Looks good. Looks good, looks good. All of this looks good. I'm happy with this. Going down. I think we're fine. Let's save it. And we'll do the last one. These biomarkers here all look correct to me. Scrolling down. Good. But we noticed there were a few mistakes that the LLM annotator made. So let's do guideline refinement. So based on the changes that we made to those annotations, we've established this new ground truth. We're now going to go through an iterative process of improving our annotation guidelines, and that's actually an automatic thing that happens. So right now we're automatically generating new guidelines that we think will do a better job at annotating our new modified ground truth. We'll wait a few seconds for this to complete, and then we'll continue. So that's our old one. Let's look at the new one. This looks pretty good. Let's accept it. Notice how it's saying, like, for example, do not label things related to diet and test statuses that don't have results given, etc. All right, I'm happy with this. So with our new set of annotations, we're now going to, or with our new set of annotation guidelines, we're going to re-annotate the files, and then we'll compute some new F1 scores. Let's wait for that to finish. Okay, so we've now re-annotated our data, and we've computed precision recall and F1 scores for our new files. In general, we're doing quite well, especially for only iterating once, but we could actually improve this a bit more. So I'm going to go back to the suggestions here, and I've kind of played with this a little bit before, so to save time going back and forth with the LLM on iterating, I'm going to paste in a new set of annotation guidelines that I know to work well. I'll save this new version. We're going to re-annotate one more time. All right, our latest set of scores are coming in, and you can see we're a lot higher now. The 2 last files we're now essentially perfect on according to our ground truth, and files 1, 2, and 3 are also in the high 0.9s or perfect themselves. So I'm now happy with our new set of annotation guidelines. We're doing a really good job at annotating the first 5 files. But of course, I can't train I can't train an NER model with just 5 files. There's not enough training data there. So let's now add a lot more files. I'm going to upload not 5 files this time, but closer to 700 additional files, 750 actually. Let's open that up. So now we know our annotator works good on the first 5 files. The other files we have are all very similar in nature, so we're confident that our annotator is going to do a good job of pulling out the entities in the rest of the file set. So we're analyzing everything now. Everything's looking good. Let's begin model training. The model training is going to happen after we finish annotating all 700 files, or 750 files, and then it's going to fine-tune a BERT model. So let's do it. We're going to do it based on version 3 of the guidelines that we've established, because those have the best scores. I'm going to save it. And there's going to be a 2-step process. First, we're going to have to annotate all of our files. This is going to take maybe 10-15 minutes. And then we'll go through maybe a 10-minute process of actually fine-tuning our BERT model. And once the fine-tuned BERT model is available, we can start actually using it to identify new PII or do new types of entity extraction on our data. So the annotation process has begun. Now I've already gone ahead and actually trained this model because I didn't feel like waiting another 30 minutes just for a video. So let me show you what it looks like to actually now use this model on some real data. All right, so here we are in Visual Code. I've copied in a medical note that we're going to run through our new models. This will, of course, run it through both our base models and also our custom models that we've trained on our own data. But right now what I'm going to do is run this through, and I'm only going to print out biomarkers that we find. And I can do that by filtering to our new entity label right here. So let's run it. And you can see that we're finding now all of our biomarkers in the data. WC is 4, RBC is 4. Oh, it's getting cut off. Let's see if I can fix that. Okay, there we go. So now you can see all of your biomarkers, urobilinogen, normal, Ketua is 3+, etc. Right? So we're able to essentially pull out all of these new entities that we now care about. And of course, you can use this feature not just for biomarkers, you can use it to train any type of new entity detection that you need, whether it's for identification and redaction or simply for entity extraction. So you can get as specific as you like and even do it on things that are relevant only to your data sets because it trains on your data and creates private NER models just for you. Thank you.